This is a short tutorial to show how to deploy Ekisa ScreenLogger version 5 on a development machine with the software development kit. I am going to use a single machine for this deployment. Normally one would have the ScreenLogger workstation software deployed on dozens, hundreds or even thousands of machines in a call center. But for the purpose of this tutorial I'll be installing all the software on a single machine. First, download the software from the Ekisa website portal and place them in a convenient folder. Start off by installing the ScreenLogger configurator service. This is the central command and control software that manages the entire system. Simply run the executable, accept licensing terms and conditions and use default settings. A system name is required on this screen, but we are going to ignore it as it is only used for cloud server deployments. We don't need it for local recording. The installer completes after a few seconds. The next software that I'll be installing is the ScreenLogger Screen Server service. This is the component that stores the screen recordings and performs routine circular storage housekeeping. We need to provide the name of the machine that hosts the configurator service. In this case it is the host name of this machine, Ekisa WS1. Note that in call center deployments where the machines operate on a domain, the fully qualified domain name is required. As before, we can ignore the system name as this only applies to cloud deployments. After a few seconds, the installation is complete. If I open Windows Services and scroll down to Ekisa, there are two Windows NT services for Ekisa ScreenLogger, the one for the configurator and the other one for the screen server service. Next, I am going to install the ScreenLogger Management Studio application, which is the user interface to configure and manage the system. Let's open Management Studio. It starts with the connection screen and here we need to enter the name of the machine that hosts the configurator service again. Click on Connect. The system window shows license and capacity information. As we are using ScreenLogger in trial mode, limited temporary licensing is available for 2 dedicated recording licenses and 1 concurrent recording license. We can see over here the screen server service is running and online, but it's not associated with the system yet. Sign in using the demo username and password. Drag and drop the screen server onto the ScreenLogger system node. Now we are ready to install the ScreenLogger workstation software on the same machine. When done, restart the machine. After the machine has restarted, open up Management Studio and connect to the configurator again. We can see that the workstation software has successfully been detected and is automatically associated with the screen server. The state of the workstation is in session, which is indicated by the light blue background and means that the workstation is ready to be recorded. Sign in using the demo credentials and select the one and only workstation. Note that the Google VP80 codec is selected by default. Recordings made with VP80 are exported to WebM file format which is compatible with HTML5 web playback. On the other hand, recordings made with the XVID codec are exported to AVI file format which is not allowed by default with HTML5 web playback. The XVID codec is therefore more suitable if the .NET Framework API is used. If the XVID codec is preferred, the XVID codec driver that has been optimized by Ekisa for the ScreenLogger system must first be installed on the workstation. This driver can be obtained on the Ekisa website. Navigate to ekisa.com/codecs/xvid.htm. Click on the link to download and run the installer. I am not going to use the Xvid codec in this tutorial, as the default VP80 codec can be used for both the REST API and the .NET Framework API. Next, we're going to install the software development kit on the same platform. Run the installer. As before, accept licensing agreement and default values. The SDK is installed in the Ekisa ScreenLogger folder of program files. Here are DLLs, sample code and documentation. Open the sample code folder. Here are two examples with source code, one for the .NET Framework API and the other for the REST API. Let us first look at the REST API. In the HTTP test app folder you will find the Visual Studio project file and all the source code to build the sample application. In the release folder is a precompiled build of the executable. Run it. On the left-hand side are the URLs for the REST API's root and endpoint, followed by the request body and the response header and body. On the right-hand side are some useful shortcut commands and controls. To start up, sign in and use the demo credentials, then click on Login. The request and subsequent response can be seen on the left. The response is successful and it provides a token that needs to be used in subsequent endpoint calls. For example, let us query the licensing information. This is the result. The trial evaluation period allows recording of 2 static workstations and 1 dynamic workstation. It basically means we've got 2 dedicated recording licenses and 1 concurrent recording license. I entered the name of the workstation, Ekisa-WS1, let's start a recording. You can see here that it has successfully started. I'm going to open a web browser to show the current time. I am stopping the recording. I can play it externally in Chrome because the codec is the Google VP80 codec. For an integrated solution, the video player will typically be an HTML5 media control. Let us play it back in Management Studio. Here we can play back and observe the desktop activities in the screen recording. A last word of advice on the REST API. On a new machine or a machine that has a new standard Windows installation, Google Chrome is not installed. Attempting to play back the screen recording from within the REST test application will show an error unless Chrome is installed. Now we shall be looking at the .NET Framework API. In the sample code folder of the SDK, open the folder that says .NET Test App. Here is also a Visual Studio project file and the source code of the sample application. Open the release folder and launch the precompiled executable called testapp.exe to open the user interface. As before, we're going to enter the name of the configurator machine name and sign in with the demo credentials. It connects successfully. Start a test recording. Let's get the current time to display in the background. or place it next to the sample app. I am going to stop the recording now. Here is the recording ID, also called the event ID. As with the REST API, there is functionality to get information about a recording. It shows the codec used, the number of frames captured, the name of the screen server where it is stored, and various other parameters of the screen recording. We can also get session information. Let's play back the screen recording. I'll increase the playback speed. There is more functionality in the .NET Framework sample code. Here is a method to retrieve the name and details of all screen servers, all known workstations, and all agents. One can search for sessions in a specific time period. And then there is a very useful utility called the test runner that can be used for large-scale load tests on the system. At the moment we only have one single workstation, but there may be dozens, hundreds or even thousands of workstations. These are not simulated recordings. The test runner will generate actual recordings. By default the recording duration is between 10 and 60 seconds and the idle time is between 5 and 10 seconds. For now we're going to decrease this to have screen recordings between 6 and 12 seconds with the idle time between 5 and 7 seconds. Let's start the test runner. First, the workstation state is idle, then it starts recording, and after a few seconds the recording is stopped again. We can add additional workload to export recordings. For this we need an export folder which will contain the exported recording files. There is a notification to remind us that we are recording workstations which may contain confidential information, and that one should proceed only if proper authorization has been obtained to do this. Let's add playback to the test suite as well and run it. Here we can see that after a recording has been started and stopped, it is played back and then exported. This process repeats for as long as we want. The test runner can be very useful to test the system's reliability, especially for large and distributed systems. This is the end of this demonstration. If you have any questions or any issues when deploying the SDK on a development environment, please contact Ekisa support on support@ekisa.com. Thank you for watching.